I've recently realized that the internet is flooded with questions like, is it better to major in mechanical or aerospace engineering? Or what's the difference between computer and electrical engineering? And honestly, I can't blame you for asking these questions because there's literally so many types of engineering like chemical, civil, mechanical, software, electrical, industrial, aerospace, etc. So, as someone who recently graduated from mechanical engineering and has had quite a bit of experience interacting with other engineering programs, I'll attempt to explain every engineering program in this video. Universities like to make it seem like there's so many types of engineering programs out there, but there's really only 5 that I like to call the big 5: mechanical, electrical, software, chemical, and civil. All other engineering programs are either a mix of 2 or more of these categories or are a smaller subsection within a particular category. First, I'll explain each of these 5 categories in a little more detail, talking about what it actually is, what kind of courses you can expect to take, and what you can expect to do with this degree after you graduate. Afterwards, I'll explain how all the other engineering programs relate to the big 5. You'll also find timestamps for everything in the description. Let's start off with mechanical engineering. Mechanical engineers focus on designing things and getting them built. For example, a mechanical engineer will focus on the design of this mouse, determining what material it should be made out of so that it's nice and smooth but doesn't easily scratch. You'll also find yourself taking courses in statics, which is the physics behind things that don't move, dynamics, which is the physics behind things that do move, fluids, which is understanding how to control air and water, thermodynamics, which is understanding how to control heat, and finally mechanical design, which is understanding the difference between many materials and all the manufacturing process that exists out there to build everything you see around you. You may also find yourself taking some programming courses like MATLAB, for example. The types of jobs you can expect to get after graduating first include product design engineering, which essentially means designing how a product like this Apple Pencil, for example, would look like, what materials it would be made out of, and what manufacturing process would be used to make something like this. Second, we have manufacturing engineering, where you essentially become an expert at predicting when products will fail and how to avoid them. You essentially focus on creating high quality products while keeping the cost relatively low. Third, we have automotive engineering. So for example, making the engine of a car more efficient, or working on the overall mechanical design of a suspension system, or maybe designing the car in such a way so that it's more aerodynamic and it could move faster. Fourth, we have HVAC, where you're essentially working on maintaining a comfortable temperature inside homes, buildings, offices, gyms, etc. Next, let's talk about electrical engineering. Electrical engineers will build devices like motors and navigation systems. For example, an electrical engineer will focus on the wiring and circuitry that goes inside this iPhone. They'll also be responsible for how this iPhone communicates with other phones. They use radio frequencies for this type of communication, which is something that you'll learn all about if you choose to study electrical engineering in one of your courses. Speaking of courses, these are some of the basic courses that you'll find yourself taking if you choose to pursue electrical engineering. First, we have an electronic circuits course, where you'll learn how to analyze circuits as well as how important transistors are for all modern electric devices. Second, we have data structures and algorithms, where you learn how to collect and organize data in a computer to basically make it do what you want. Third, we have signals. You see, the voltage in all of your electronic devices is expressed through signals, and so this course will teach you how to interpret them so you can actually make good use of them. Fourth, we have communication systems, where you essentially learn how different electronic devices use radio frequencies to communicate with each other. And finally, electromagnetism, where you'll learn about the physics behind electricity and magnetism and how electromagnetic waves impact the environment around us. Now, for an electrical engineer, there's a bunch of jobs you can expect to get after you graduate. First, we have a hardware engineer, where you design and test the physical electrical components that go in all of our electrical devices. Second, we have an electrical designer, where you design the circuitry that will allow electricity to flow through our systems. Third, we have a programmer, where you can just write and test code. And fourth, we have a firmware engineer, where you essentially take electrical signals and turn them into useful tasks that a computer can do. Next, let's talk about software engineering. Software engineers build large-scale software systems like maybe Microsoft Office, social media apps, or video games. For example, looking at this iPhone again, all the apps you see on the phone and the operating system on the phone were all created by a software engineer. The types of courses you can find yourself taking in software engineering first include programming, where you'll learn how to code in several programming languages like Python, Java, etc. Second, we have algorithm design, where you learn how to develop software algorithms to be able to solve problems. Third, we have computational logic, which essentially teaches you how to think in a very abstract way. Fourth, we have data structures and algorithms, where you essentially focus on collecting and organizing data to make a computer basically do what you want. Fifth, we have operating systems, where you essentially understand the fundamentals behind the operating systems that make all of our electronic devices operate. The types of jobs you can expect to get after you graduate first include being a software engineer, where you work on designing the software behind things like apps or video games. You can also end up working as a web developer, where you create and maintain the coding behind websites. Next, let's talk about chemical engineering. A chemical engineer is someone who designs processes that will go in power plants to produce materials. They can work in the pharmaceuticals or biotechnology field to design processes that will create drugs and other medications. They can also work with electronics to design the chemical process that will create the electronic chips that we see in all of our devices. They can also work on the chemical process that produces soaps and laundry detergents. Also, chemical engineers can work in the food industry for companies like Pepsi, Nestle, etc. Finally, the petroleum industry is pretty huge for chemical engineers because they can work on designing the process that will turn the crude oil that we can dig up from underneath the ground into the gas that we put in our cars. For this program, you'll take courses in, chemistry, such as organic chemistry, physical chemistry, and general chemistry. Other engineering programs take chemistry as well, but definitely not as much as chemical engineers. Second, we have heat transfer and thermodynamics, where you understand how to control heat and temperature. Third, we have process design, control, and analysis, where you learn how to optimize plant performance as well as design new processes. Third, we have material science, where you understand the fundamentals behind all the materials that we see around us, like metals, plastics, ceramics, etc. After you graduate, you can expect to work as a process engineer, where you essentially design and optimize processes that use heat, pressure, and chemical reactions to turn raw materials like oil, natural gas, and milk into usable products like toothpaste, butter, cheese, etc. A civil engineer is someone that designs buildings, bridges, roads, tunnels, etc. Civil engineers usually have 4 categories: structural, geotechnical, water resources, and transportation. Structural engineers focus on designing large and heavy structures that are able to withstand their own weight and not collapse. That includes things like bridges and buildings. Geotechnical engineers focus on the behavior of earth materials like rock and soil. So for example, the soil that will be connected to the bridges and buildings that the structural engineers design is the responsibility of the geotechnical engineers. They need to make sure that the soil that the structure is connected to is able to withstand this large load. Next, we have water resources engineers, and they're responsible for designing things like dams, pipelines, canals, or water facilities to control the distribution of water within our cities. Transportation engineers design streets, roads, and highways. They need to determine how many lanes we need on our roads and our highways, as well as how cars should merge to keep everyone safe. As a civil engineering student, you'll find yourself taking courses in first, statics, which is essentially the physics behind things that don't move. Second, we have structural analysis, which is understanding how things like wind and earthquakes can impact our bridges and our buildings. Third, we have transportation courses, which goes over the fundamentals of the design and optimization of transportation systems in our cities. Fourth, we have geotechnical process courses, which will teach you the fundamentals behind the soil that our buildings and bridges will lay on top of. Fifth, we have a fluids and hydrology course, which will teach you about the water cycle, flood frequency, and storm design. Now, the jobs you can get with a civil engineering degree include structural engineering, transportation engineering, tunnel engineering, project manager, or field engineer. Field engineers spend most of their time at the actual construction site and less time in an actual office. Now that you have a better idea of what the big 5 engineering programs are, you're probably wondering, what about all the other engineering programs? We can't just neglect them, right? And you have a point, so let's talk about them. First, let's talk about Mechatronics Engineering. Mechatronics Engineering is basically a mix between mechanical, electrical, and software engineering. And so what that really means is going through this program, you will be able to get a job in any of those categories. However, once you graduate, most people usually just pick one of those categories and just focus on that. That being said, if you're unsure about what kind of engineering you want to get into, then Mechatronics Engineering might just be your best option because it gives you the opportunity to learn a little bit about the 3 main categories of engineering. Next, we have computer engineering, which is a mix between electrical and software engineering. So if you for sure know that you don't want to do mechanical engineering, but you're undecided between whether you want to do electrical or software engineering, then computer engineering might just be your best bet in this situation. Next up, we have systems design engineering, which is essentially a mixture between electrical and software engineering with a hint of mechanical engineering. So in a way, it's in between mechatronics and computer engineering. But to be honest, most system design engineers end up working in software anyways. Next, let's talk about automotive and aerospace engineering. This is an interesting one in my opinion because you can use your mechanical, electrical, or software engineering knowledge to work in those fields. This is because you can work on cars, rockets, or planes with either your mechanical, electrical, or software knowledge. For example, you can work on the mechanical design of the seats in a car, which is what a mechanical engineer would do, or you can work on the lighting system in the car, which is what an electrical engineer would do, or you can work on the software that will make cars self-driving, which is what a software engineer would do. The same thing applies to biomedical engineering. This is because you can work in the biomedical industry as either either a mechanical, electrical, or software engineer, and you don't need a specific biomedical engineering degree to work in that industry. You can either design the shell of a prosthetic arm as a mechanical engineer, or you can work on the electronics and circuits and wiring that goes inside the arm as an electrical engineer, or you can work on the software that makes that arm move as a software engineer. Next, let's talk about environmental and geological engineering. Both are just smaller subsections of civil engineering, so they'll fall under that category. Next up, let's talk about industrial engineering, which is essentially a mix between mechanical and chemical engineering, as they just focus on taking processes and designing them in a way to be more efficient. But that said, these are the main engineering programs out there explained, and if you're deciding on what kind of engineering program to get into, I hope this video brought you value. I should mention though that if you're interested in working for big tech companies like Apple, Google, Facebook, Uber, etc., then your best bet would be to go into programs like mechanical, electrical, or software, or any of the degrees associated with those three main categories. And just to reiterate, mechanical focuses on the outer design of this iPhone and the material used to make this iPhone. Electrical focuses on the circuitry inside this phone and how it communicates with all the other electronic devices, and software focuses on the apps and operating system that goes inside this phone. Chemical and civil engineering are still really cool too, but from my experience, most people who graduate from those programs don't necessarily end up working in these big tech companies, so something to keep in mind if these companies are something that you are looking into. Anyways, I hope this video brought you value. If it did, please make sure to like and subscribe, and I'll see you in the next one. Peace!